Hello and namaste. Welcome to MCQ Sets. We are talking about the computer networks in this video series, and this is the second lesson. And today's video is about transmission media. I'm Suresh Khanal from mcqsets.com. You can visit the site mcqsets.com to read more about the computer networks there. Please go to the reading section and computer fundamentals menu. Today in this video we are covering two major aspects like the what is transmission media and the types of the transmission media. We will talk about bound transmission media and unbound transmission media. First of all, let's begin with what is transmission media. Like here in the image, you can see a computer network connected with the server, computer, router, Wi-Fi router, switches, IP phone, desktop PCs, scanner, printer, etc. So all these devices are connected with each other and this network is formed. Now in this network, for data to travel, there are paths. Like this PC is connected with this switch through this cable. So this cable is the path for the data to travel from this PC to switch or from this switch to PC. Similarly, the Wi-Fi router is connected here with the smartphone, laptop PC, and another laptop PC. So data from this Wi-Fi router will travel and reach up to the smartphone. Similarly, from a smartphone back up to the router. So this way, the path through which the data can travel in a network, that is known as transmission media. So the transmission media essentially is the connections. It can be the cable connections or it can be the wireless connection. Whether it is wireless or it is the cable connection, and the data can travel through them. So they are the transmission media. And when we talk about the transmission media, it can be guided or it can be unguided. Guided is called in such situation like this desktop PC is connected with the switch, and the electrons carrying data from this desktop PC can travel only through this cable to reach up to this switch. So here those electrons, those data are guided through what to travel to reach up to the destination. So the cable connections, they are often known as guided transmission media. There's another word also, the bound transmission media. Bound in the sense that they are bound by physical geography. You cannot extend the cables very far, or in some situations, in some geographical situations, you cannot draw the cables like the mountains, your sites when they are being obstacled by the mountains or the large building in between. So in many situations the cables cannot be used. In such situations you can use unbound transmission media or the wireless connections. So let me read the description given for the transmission media here. Transmission media is the pathway through which data travels in a network. It can be guided as in cables or wires, and also unguided transmission media such as in wireless transmission. Here we talk about the bound transmission media, the term. In the same computer network, all these cable connections, they are the bound transmission media. Cables used to connect the different nodes of network. The nodes, each device connected in the network, they are known as a node. So this switch is a node, another node, this desktop PC is a node, and this router is a node. So this way, every device that connects to the network, that device is one node. Well, cables used to connect the different nodes of a network are also called bound transmission media, as they are bound by physical geography. Okay, the next one. Thus, for wireless connections, like here, the Wi-Fi router is connected with the laptop PCs and smartphone. For these connections that are not bound by physical geography, they are called unbound transmission media. Okay, now it's time to look at the types of transmission media. As we talked earlier, there are two major types of transmission media: bound transmission media and unbound transmission media, or we can say guided transmission media and unguided transmission media. In case of the first type, in case of the bound transmission media, we have got twisted pair cables, coaxial cables, and fiber optic cables. You can use these cables to form a network. And in case of unbound transmission media, we have got the microwave, radio wave, and infrared. These are the wireless network connections available. So these are the two major basic types of transmission media, and we will look into the bound transmission media a bit closer. Bound transmission media, the type of media that is bound by physical geography, such as cables, are known as bound transmission media. Twisted pair cables, coaxial cables, fiber optics cables, etc. are the examples. In the image, you can see the two types, two different bound transmission media. On the left is the twisted pair, whereas on the right there is the optical fiber. Two different kind of the transmission media that works pretty different with each other. So anyway, whatever, they are the cables. They connect the devices physically and they guide the data to travel through. So these are the bound transmission media. And in bound transmission media, we further look into the twisted pair cables. This twisted pair of cables is a pair of cables twisted with each other. Essentially, the conductor, usually it's the copper wire that is insulated, and this wire is twisted with another wire to form the twisted pair. In case of computer network cable, we have got four pairs of twisted pairs. Like here you can see the blue and half blue are twisted with each other, orange and half orange are twisted, similarly the green and half green, brown and half brown. So the four different pairs of twisted pair cables, they are packed inside the jacket and makes up the twisted pair cable for computer connections. In the left you can see the image of the twisted pair cable in a bundle, and on the right the image displays four different pairs separated. The text over here is a pair of wires twisted with each other. That's the twisted pair cable, very simply. The conductor, usually copper, is covered with an insulator, and four pairs of such are packed inside a cable jacket to make a network cable. This is the twisted pair cable. And in twisted pair cables, we have two different types, the UTP and STP. UTP stands for unshielded twisted pair, whereas this STP stands for the shielded twisted pair cable. Okay, the difference between these two is the first one is not shielded. It doesn't have another extra protective layer over here, whereas in STP cable you can see the protection provided. That's the major difference. And why this is required? It's for the situations when your networking site is affected by powerful magnetic field or electric field. As you know, the powerful magnetic field and electric field, this can disrupt the data flowing inside the cables. The data that's flowing inside this copper wire can be disturbed by the powerful magnetic force or the electric field. So if that is the situation of your installation site, then the UTP cable is not a good choice. At that time you must go for the STP cable. But if your site is free from those problems, UTP cables are pretty sufficient. These are a bit cheaper than the STP cables and works pretty fine. And here in this image you can see the four different images for the four different types of twisted pair cables. Essentially not the types but the categories. That's why they are said the cat 5 cable, cat 6 cable, cat 5e for category 5 extended, this cat 5 cable, and this is the category 6 cable. It's given more strength, and the data transfer speed over cat 6 is faster than the cat 5. Similarly, you can see look at here at the cat 6a, which gets the shielded over for the twisted pair, and in case of cat 7 it has got a solid copper wire and a good shielding to make it a very reliable and good cable for networking. You might not need this depth to learn everything about the cat 5, cat 6 and what these categories are, what's the differences and other technical specification. But if you are interested to read more about it, you can visit this link given at the bottom of this screen. The Kerry Zhang has written a very nice article about the different categories of these cat cables, these twisted pair cables. Now here in this image I display the RJ45 jack. This is the terminator for the twisted pair cables. These twisted pair, the cables, they are connected with this RJ45 jack, and this RJ45 jack you can connect to the switches, routers, or even your PCs. Let's look at the next slide. like here. That RJ45 jack can be inserted inside these ports known as the RJ45 ports. RJ stands for registered jack. The 45th number is for the network cables, so network jacks, that's why they are called RJ45. And even in your PC, you can, at the back of your PC, the CPU box, you can see the RJ45 jack over there, and here you will insert, here you will connect your network cable, that RJ45 jack inside here. And also you can see another smaller one. This smaller one is RJ11. This is the registered jack number 11. It's for the telephone cables, the telephone jacks. If you use your PC to connect to the network through the modem, then you might need this port. The next one here is the USB port. You very well know it. You can connect your mouse, keyboard, and here a lot of other devices to the PC through this USB port. And mostly we insert our pen drives or the flash disks on this port. Okay, let's proceed. Well, we talked about the bound transmission media and twisted pair cables inside bound transmission media. Now we will go towards coaxial cables. The second type of bound transmission media is coaxial cables, and it's very popularly being used in the television, cable televisions. So this is the coaxial cable structure. A central solid central conductor surrounded by insulating material, and then by a cylindrical shield woven from the fine wires. This one is known as the coaxial cable. Generally, this copper carries the data, and this the fiber, these woven wires, they are grounded to protect it from the EMI or the electric disturbances. Well, this is the this is the coaxial cable. You can see the copper wire inside here, insulation, copper mesh for these weaving wires, and the outside insulation, the protective layer is there. So this is the coaxial cable, and in the next slide here I display a few connectors. Like this is the connector, BNC connector for connecting the coaxial cable with the devices. If your computer should be connected to the network where this coaxial cable is used, you might need a NIC card, network interface card, having this connector. Then only you can connect your network cable to the PC. Well, this is the connector. And now the third type of bound transmission media is fiber optics cable. Let's look at it. Well, here is the structure of the fiber optic. A cable with the central glass tube, which is over here, the glass core, and this glass cladding. These two things, the central glass tube covered with protective shield. We have got primary buffer and secondary buffer, which transmits data using photons, is fiber optic cable. Here the important thing is, in fiber optics, it doesn't carry electrons. The data is sent not as electric signals, but rather as optical signals. These cables transmit data via concentrated bursts of laser beams, which are carried through bundles of hair-thin glass of fibers. So in the fiber optics cable, it's not the electrons, but it's the photons, the pulses of light that travel through this glass. And this core and cladding, two types of glasses are used so that the total internal reflection is possible, and the light enters from one end, will not disperse, will not be absorbed, but reach up to the another end. For that purpose, the two different index factors glasses are used to make the fiber optics cable. Okay, and here you can see the fiber optics cable. Another image is here with lots of the glass fibers covered with the protective layer further and strengthen. The outer jacket is over here. This is the real physical image of the fiber optic cable along with the connector. You can see the cable here, this one, two fiber optic cables are there, and the connector is there. So this is a physical look of this fiber optic cable. And here in this slide you can see the different kinds of connectors for the fiber optic cable. So they are terminated with these connectors, and you can connect them to the networking devices and your PCs. Well, these were the bound transmission media. We talked about twisted pair cables, coaxial, and fiber optics. Now it's the turn to go towards the unbound transmission media or unguided transmission media. Unbound transmission media extend beyond the limiting confines of cabling. As we talked earlier, as the problems of the cables vanishes when we use the wireless connections. They provide an excellent communication alternatives for WAN. In case of LANs, when the nodes, they are pretty closer with each other, nearer, then you can use cables fine. But in case of WANs, wide area networks, it won't be possible to connect every devices using the wires or using the cables. So in such situations, the unbound transmission media can be used. The lack of physical restrictions provides larger bandwidth as well as wide area capabilities. Unbound media typically operate at a very high frequency. Well, the three types of unbound transmission media are radio wave, microwave, and infrared. Here you can see the radio wave. Two antennas are used. If this antenna needs to send data to the next antenna, it has got the transmitter which will convert the data into the electric signals and throw through the air, and the receiving end will receive those electric signals, those electric power, and it has got the receiver that will translate, that will convert those electric signals into the data and send to the other devices. So each of these stations should have transmitters and the receivers. Combined, they are known as transceivers. Well, radio waves makes it possible to connect the network when running cables is difficult or more expensive. In some situations, cables might be more expensive than using the wireless technologies. In wireless networking, air is the vehicle through which data is carried, just as Ethernet uses copper cable. Like in the Ethernet technology, we use the copper cables for the data to travel. But in case of wireless networking, it's the air itself is the medium through which the data transfers. Okay, here in this slide you can see the different kind of radio waves being used for various purposes. You might not need to go very depth up to it. Anyway, there's a link given at the right hand side if you are interested and want to study more about it. The next type of unbound transmission media is microwave. It has been used in data communication for a long time. They have a higher frequency than radio waves and therefore can handle larger amount of data. The benefits of microwave is that it has got more bandwidth. Microwave transmission is the line of sight transmission. Here the thing to note is that it's a line of sight transmission, means the transmitter and the receiver, these two should be on the same straight line, on the same line of sight. If you see from here, you must look at this one. If you look from here, you must see the receiving end. So on the same line of sight it must be. The transmitter station must be in visible contact with the receiving station. This sets a limit on the distance between the stations depending upon the local geography. Sometimes for the hilly type of geographical conditions, and even because of the earth curvature, even if the land is very flat, you cannot go beyond the 50 kilometer to the horizon. And repeater stations must be placed so that data signals can hop, skip, and jump across the country. If you need to cover a very large distance, then before this 50-kilometer distance, you must place a receiving station, repeating station, so that will receive the signal from one antenna and amplify it and send it again to the another distance, to the another station. Okay, that was the microwave, and finally we have got the infrared here. Infrared offers a great unbound photonic solution. Like in bound transmission media, we had the fiber optic cables that carry data as light pulses. Similarly, here in unbound transmission media, we have got infrared that works in the light principle rather than the electronic, or rather than the electric pulses. Unlike fiber optic cabling, infrared communications use light, so they are not bound by the limitations of electricity. The advantage of using a photonic solution is free from the electric and magnetic interference. So it's the unbound transmission media and uses light. Okay, so these were the different types of transmission media, and here ends our session as well. Thank you very much for your time, and you can visit mcqsets.com to read more about the computer networking. There's a page, really a large page about computer networking. Just visit the site mcqsets.com and go to the readings and fundamental. You will find a post about computer networking there. Okay, we will see again in next video. Till then, see you.